So what we've got for this code is we've got a problem, and we have a roommate that's coming into the room late, and they're switching on lights, and that's going to wake up the other roommates that actually studied before they played Minecraft parkour and are super tired and trying to go to bed. So what do we do? First, we're going to use some sort of input. Um, Let me know in the chat if if we want to know when someone comes in, what's the easiest sensor to use for knowing when somebody comes in for this circumstance? What thing on the board can we use to know when somebody comes in the room and flips on the light? Okay, good, light sensor. So we're going to start reconfiguring here. Um, so we're going to choose the input from the light sensor. So we're going to say light pin. And where is that on the board? Everyone take a quick look at your board and remember where that pin is. Also, for the question earlier about the coolest project, there's been a lot of very interesting things. I have seen as far as Arduino boards used as the main control board for entire 3D printers and things of that nature. So I've seen people that have made with an Arduino and a bunch of other components a whole new 3D printer out of 3D printed parts. And so it's not quite a machine that can completely replicate itself, but it's pretty close. Um, People that still think that the Terminators are going to take over have not had the opportunity to do coding and figure out just how freaking absurd that entire idea actually is. Without someone to have done all of the hard work of writing and compiling and developing the code, and the kiddies that quickly jump in with the defense, uh, these are, even if you had something like an AI, which we have to remember is just code that's doing a thing, even if you had AI write the code, you still had to have somebody write the code that wrote the code. And so you get into a whole inception thing, except it's codeception. It's a whole thing. Yeah, the Arduino can actually be very, very powerful, but you need a much, much bigger Arduino board. They call it the Mega, in order to really have enough IO space available on the board. You got to use a lot of external relays and things for high current stuff. So it can be actually a little bit dangerous to do a project like that. But I've seen a lot of very interesting ones. So this one, the PIR state, we're not going to use the PIR sensor. So this is a IR sensor type that you can get. Our sensor is not quite as sophisticated, but it still allows for some degree of RGB level determination and some things like that. So we're going to eliminate these because we don't actually need them for what we're doing. So this is set up the input, really. Set up the input for light pin that we'll use later. This is this is defining the constants for the needed note frequencies. So these don't actually need to be adjusted. The buzzer pin for our purposes is not here. It's actually going to be let's see if you guys remember. Where is the onboard speaker output? See if you guys can find it again on your board. Good. So we're going to use speaker pin. And again, I don't know if it's going to work correctly with these frequencies. We're going to find out because reasons. So LED pin 12 and 13. We're not going to need these LED pins. Oh, that's what I was doing with these. Okay. We're going to leave one LED pin. Yeah, we're going to leave one of them. It's going to be pin 13. So this LED pin I use as a diagnostic. So when so this is already set to output. I'm going to replace that one. And I'm going to find there's, I think, one more. Yeah, there's a bunch of little stuff that we've got to do here. I'm going to find all these buzzer pins and replace them. I know you can use the replace all instances, but I didn't remember what else is here, so I wanted to physically refresh my memory. Okay. Because we want these things to run, I'm actually going to bring these up. So this is actually a great way to introduce functions, as a matter of fact. So I guess we're technically learning early. Before we run the setup, we're going to run the other classes up here. So beep is one of them. So I'm going to bring all of this stuff up to the top. Recall that we have seen some functions earlier. I want to clarify a couple aspects of what a function is doing, and this is actually a great way to do it. So here again, I'm teaching you levels and layers of things at the same time because I find it's the most effective method. It's nice to study about something in a book, but you need to actually put teeth to it for it to make any sort of sense. The best way to understand how something is put together is to take it apart and look inside, typically speaking. It's how the entire field of medicine was done, mostly with cadavers most of the time. So we have beep is the first one that we're going to be defining. So we have void as our class output type because we don't want anything back from this function when it runs. That doesn't mean that we don't want it to do stuff. That just means we're not looking for it to print out like the number 32 on the screen or something at the end. So void is means we don't want anything back in terms of what the output is. So we give it a name, beep, and we give it conditions that we're going to use inside this function. What this function is going to do is going to take this and this, whatever the input is, and it can be 2 inputs, it can be 35 inputs. You probably generally want to try and keep it down to fewer inputs so that you don't have to overly specify something. Just a good rule of thumb. You want to try and minimize the number of inputs to the function to what you need. And if you have an extended customized version, you make that a separate function. And if you're really modular and efficient with it, you could actually use your second function that could call the first function as long as the first function's been defined somewhere else. So we have to define this before we can use it. So what is beep? Beep is something that's going to take this integer called note and this other integer called duration, and it's going to do stuff with that. Tone is another function. So we're calling another function which is not in fact cheating. It's just something that we have to do often. Instead of writing out all of the things and defining what tone is and having another 100 lines shoved in here to make this work, tone is one of the functions that's native to the default Arduino libraries, so you should have access to it. Will it give us any info? Come on. Tone should have a definition. Yeah. No. So we're not using tone. We're not defining it in this particular scope. So I think it's one of the ones that's built in. No tone is then another function that turns that off. There's a good reason for that. We'll come back to it. So back to beep, we're telling the tone what speaker pin, what note, and what duration we're going to need it to play a tone for on the buzzer pin. I'm pretty sure tone works since this is the backbone of this particular project. I think tone works with this particular part number on the CPX, but I don't remember if I've tried it. So we'll find out together. It's an adventure. It's like a choose your own adventure book, only I get to choose all the decisions. It's really great. So the condition is we start counter at 0. So this is a a global, meaning public, variable for indexing. What this means is, because we're defining it out here outside of the other functions, we're going to be able to use counter not just inside of here. So this, however, note and duration are two variables that we're defining as part of our definition of what the beep function is. So it's going to call on another function which plays a tone, and this tone takes the note and turns that into a sequence that it can output for a specific duration to pulse the speaker at this frequency called note. The speaker that is connected to this pin address, and the duration is how long it plays that tone for. So again, I'm pretty sure tone works with this. If not, we're going to have to come in and make a revision to this, and that'll be pretty interesting. So we'll still use beep, but we'll have to do it differently with one of the Circuit Playground commands for the speaker. So I'll have to look up some specifics if we encounter a snag there. So the if counter is even, meaning if it's an even number, if counter remainder when divided by 2, that's this percent operator, remainder when divided by 2 is comparable to 0. This is a different range depending on whether it's an even or odd for the counter, and this is there's a couple ways to handle this. This is not strictly needed for the function. This is more of a diagnostic tool so that you can keep track of where the clock is. So this isn't strictly necessary. So I think this, for now, I can comment out. So really what I would do here is so it's got a time delay built in, so I don't really need a delay between that and shutting the speaker off. Then there's a delay of 50 milliseconds, and then this is an increment. So increment the term counter, so that way we're incrementing counter within this, within the beep function. Okay, so what beep is going to do, I'm going to comment this out. So under edit, comment and uncomment that block. We don't strictly need it. It's something that will help us to know that the beep function, depending on how we do it, we could do it with neopixels. There's a couple other things that we could do. There's some other fun logic that we could bring in with beep specifically to use instead of these LEDs. We can use the NeoPixels um, to be able to bring the NeoPixels up, just like what we did for a couple of the projects that we've worked on. Yeah, that will technically work. All right. No tone, speaker pin, delay, counter increment. Okay. So we're going to create another function. So this is going to rely on us having already defined what beep is. And we're calling this first section. So the first group of notes. So we have the note durations of each of these. So we have notes and duration, and then we have delay. Then we have notes and duration, then we have delay. So this first section is just a function. We're saying it's void, so we don't want anything like printing out. We don't want anything back. We just want it to do the stuff inside and not bother us. So first section, no inputs here. So you don't have to have inputs to a function. Plenty of functions don't rely on an input. It's just a matter of how you've set up that specific function. So we're calling beep and then delay. Delay itself is a function. So anything that has parentheses and some sort of input. So first section, this should be fine so long as beep works correctly. And that's the thing that we're going to find out shortly. The question, however, is the sensor is either going to be a state high or low the way that this was originally programmed. So either the motion sensor was triggered and it was high, or it was not triggered and it was off. So it was high or low. This one, the light sensor, has ranges, and we want to know what that threshold needs to be. So sometimes we need to start by bringing in data on that light sensor and figure out what the response threshold is. So the second section, same deal, void. So give us back nothing. Here's the name of it, no arguments, and it's going to do this stuff. It's going to call beep several times with notes and durations. It's going to delay and then have more notes and durations and another delay. So the second section is not particularly confusing. It's just leveraging this function that we've already defined. Delay is a similarly, delay is a function, but we don't have to define delay because they've already done that in the base Arduino libraries. So here's setup. So void setup, set speaker pin to output, LED pin 1 to output. We're not using an LED pin 2, so I'm going to scrap this one. And we're going to have some sort of sensor input. And in our case, instead of input pin, we're going to change all occurrences. And we're going to go to what we defined up here as light pin. So light pin. So everything else now will be recognized as light pin. We're going to have to change a couple things in our, so light pin is input. Yeah, we really can't set input or output until the setup using the pin mode function. All right. So now we're into looking at what's actually going to be called in the loop. So here, PIR value, we're going to right click, change all occurrences, and say instead of PIR value, we're going to do light value, and we're going to do a digital, we're going to do, instead of a digital, we're going to do an analog read. Let's look at a digital read. We haven't really done much of that. We're going to look at a digital read and see what we get back on light pin. In order to diagnose that, what are we going to need to add in our setup that we don't currently have? What critical thing are we going to need? We need it on a lot of assignments.
The serial open.
Correct. So serial.begin, don't forget 9600, because if you forget 9600, you'll be chasing a lot more errors than is strictly necessary. So we want to start serial in order to make this all work. So we can do a digital read off of light pin if light value is greater than. Now, here's what I'm going to have to look and see. PIR state is PIR state was a variable to describe, it was a Boolean variable that's the output of our infrared sensor. Since we don't have that on this board in the same way, we do have an IR sensor, but it's not the same as an external PIR sensor that comes in your 162 kits. So that's what this PIR is referring to. You guys have seen these your whole lives. This is the fairly typical infrared motion sensor. Very effective trigger mechanism for operations. So if light value is greater than some range, so we can't use, well, let's try high and low and see if we can get, let's see what we get back. So so turn LED pin 1 to high. Then at the end of this, there'll be turning LED pin to low. That's better if, then a bigger if here. Else. Yeah, this needs to go back by 1 to be correctly lined up. This is an if else case. So we're going to check so if this is high, PIR state is just a Boolean. So I'm going to say let's see. Yeah, the variant 2. All right. So this first part, trying to think of what else I can use. So I can define the PIR state as, I guess I can leave the PIR state. I think that was one that was up here. Um, really, it's a Boolean. I'm going to set it to 0 initially. All right. I'm going to leave this as left in as a Boolean variable. There's some good reason to use that. To represent the light level. Essentially, high would be 1, low would be 0. Otherwise, if this, I'm going to again change all occurrences of LED pin 2 to LED pin 1. So LED pin 1, that way we don't have definitional issues. Go back through, scrub for LED pin 1 versus LED pin 2. And then we're going to check this because we've got the base actually accounted for.
Just to be sure, we changed all of the LED pin 2s to LED pin 1s.
Yes, correct.
Okay, thank you.
So this is one of the only ones, light value. Light value. Light value. We could do another one. Light val. Again, equals 0 as a starting point. It's another Boolean variable for a Boolean variable for it's effectively used as a case switcher. It's really for case determination. All right, so let's verify again. And it's just complaining about memory. Okay. Now, there is another thing that we need to do since we open up the serial port here is we need to know what the range is. So I need to, after reading this value, I need to print it back so that we have a live data stream of what's going on. So we've got this motor run was an example of some code that I developed from this called the automatic roommate slapper for when they came through the door. I'll let you fill in the blanks on what that did. Digital write. We need a printout of serial.print to see if we can even use this. We need to know light value. There we go. Needed to include the space there. Print line. Light value. So let's see what we get. First, so that we know if this is going to compile correctly. So we're going to run this. It compiles, it complains about using 4% and 7% of the memory because, life of me, I couldn't tell you why. All right, I'm going to upload so that we can see what our serial monitor looks like. Okay, serial monitor. Light value is low. Let's see if we can get it to trigger to high using the light sensor. Okay, so we can trigger it to high. Okay, so we can get it to trigger to high. So this simplifies a couple pieces of the puzzle, because we can use the light value as in the ambient room conditions. If I'm moving the Circuit Playground Express around, I'm not actually seeing even the light from the screen or anything like that. I'm not going up to a value of 1, so I'm not going what's called high in the IO space. We then, I'm trying to determine if the buzzer actually works correctly. This one, we really don't need to specify that it's output. We just need to know that the speaker pin is a 0, but I don't know if tone works on that. It should, because it should be an analog output. And I think on their speaker there is an A to D converter side, but I don't remember. Okay. So this is now a correct start. If I had an external beeper, if I set a 0, yeah, that actually sets. Let me try it this way without defining the speaker pin as output. Let me validate that and upload it real quick, because that may. There's one other thing that happens where it'll send the output to the output pin of the board itself. Okay, so we can use switching. So it's running through, you'll see the data pause when it goes to 1. So when the mode goes to high, it'll pause. It runs through the code that we're asking it to. We just don't have output to this. And I know there are a couple examples. Let me see if I can pull one. There are a couple. Let me see. There are a couple functions that we can make use of. Oh, I hope we don't have to use wire. That becomes a mess. Let's see. Let's see. Hmm. Trying to think. I actually have. I think. So I have a buzzer. Let me grab two more things. All right. This one, let's see. I think I've got one small enough. Yeah, this should work. Poor unfortunate students who are from places like California will not understand the phrase that I'm about to utter, but that's okay. Don't leave home without your Leatherman, because reasons. Okay, so our A0, and we need ground. So the red on our buzzer goes to A0. So make sure the wire itself is making contact, and to ground. Let me see if I can make that work with the light output. So it is triggered. However, since this is a 12-volt buzzer, we could have issues with connections. So it won't allow. Oh, that's unfortunate. All right. So we do have to make some adjustments in the code, is what it is. Let me see what I can make happen there. I thought I was going to be able to quickly borrow the buzzer and do the thing, but it's not always that simple. So, there's a couple variations of the speaker command. That's what I think we're going to have to replace tone with. So we're going to have to rewrite our function. Uh, okay. We can do it. All right. Yeah, okay. We can make it happen. I was trying to avoid having to write an extra function for it, but this will get us. Yeah, this will get us what we need. We're just going to replace tone with our own. Like always, because nothing in programming is easy. And at the end of the day, if you want it to do the thing that you want it to do, probably you're going to have to write it anyway. Fine. All right. Back before the setup, bring this down because I know that part of the code is working now. What I'm going to do is back up here at the very top. We're going to go, before we do beep, we're going to add yet another function, which is I'll walk you through sort of step by step. So this is now going to be make tone. Same idea, speaker pin, note, duration, because it's calling tone, but tone is not doing the thing that we need correctly. So we have to fix beep to use make tone because functions have to call functions that do the thing that you intend them to do regardless. And so we're going to use this guy had the same kind of idea that I did, speaker pin, because you name variables things that make sense. So just so that you know, I'm not actually just out of my mind. This is somebody else that wrote code that looks very similar to stuff that I do. Make tone. For this, an unsigned character speaker pin. This one is used for the purposes of speaker pin. This, even though this is the same variable name, this is not going to interfere with our instance of speaker pin. So he defines an integer x in here. He's got a frequency in hertz, which is the same thing that we're using. So frequency in hertz, that's what all these letters are. They're all constants, they're all integers. Constants meaning we're not allowed to reassign values to them. And this one really doesn't need to be a constant. That's okay. Let me see what we can do with make tone instead. So frequency in hertz, and then time or duration in milliseconds. So same idea. Now a long variable definition, he's taking the value and he's dividing this by the frequency in hertz for the delay amount, then the loop time, long time in milliseconds, times 1,000, divided by half the delay amount, because reasons. This has to do with frequencies and the rate at which human auditory processes happen. So these are some constants that are out there. This is why I didn't want to have to write this function from scratch, but we have to include it because this is what we're going to need to make use of. So I'll widen this so that you guys can actually see more of it here. Lots and lots and lots of things going on. Yeah. So make tone takes our delay time as the input and basically takes the loop time, and so long as x is below the loop time, x is the internal index variable, so that x is only going to be used along with speaker pin, frequency in hertz, time in milliseconds. All of that is only going to be used within this specific function. None of those are going to be things that we can call out of these after the fact. And it's a good thing that I checked this, because our curly brace sandwich for this for loop ends here. We need another closing curly brace to close our class here for make tone, to make sure all of this is contained. Otherwise it'll think beep is part of it and it becomes a whole big rotten mess. So don't do that. All right, so we switched out for make tone. No tone might still work, or stop the tone on the buzzer pin. This might actually be just this. Because make tone, speaker pin, note duration. And since we don't know that no tone works, this is a brute force method of replacing that function in our code. I'm going to say or the no tone is happening and it's not executing properly. I don't know what's going on there. Anyway, counter increment delay, set this to low every time we've done the make tone run through. So the delay amount by half is because of top and bottom parts of waves and not doing cancellation and some other things. There's a whole bunch of audio engineering that goes into why these numbers are what they are. So we're not going to go farther into that. We're just going to leave them in place. Yeah, now I think beep is updated such that it should be able to do the thing using make tone. And now we can do some more testing on this. Let's try and see what we get here. So I'm going to verify first, done compiling. It's probably still mad about memory. No, now it's not mad about memory. What freaking ever? Seriously. Okay, let's try this again. Okay. So we've now uploaded. We're looking at light value 0. Okay, we did get sound. It's not producing all of them. That's disappointing. So I have to let it run through the circuit, run through that code loop. It's trying. Okay. It is functioning. Okay. It is functioning. So that make tone does work. Okay. Okay. So that is working. I'm going to see now if our external connections also work. Okay. I'm going to see if we can pick it up and if it is working the way it should. I'll probably have to turn off the noise suppression. Okay. Let's see if it will function the way it ought to. Okay, come on. Come on. The connections are Okay. Let's see if those are any better. No, the analog output is not picking it up correctly. Because I think this is because it's looking for a 12-volt signal as opposed to a 5-volt scale. That's part of the issue that we're having there. So it's working. The question I have now is, I don't know if, so the beep function actually does work. And so the code is actually fully complete and working. I'm going to go back up to this section that you guys are going to need for make tone. Let me see if I can pull this up otherwise. What else can I use there? Let me see if I can pull it up I had a version of this at one point in Tinkercad. So let me know in the chat once you've figured out what this is. All right. I can't update that right now, but I can go to It's taking a while to pull up. Good, one got it. Yes, the Imperial March is correct. I'm going to share this so it will make a little bit more sense what we're working on there. Yeah, so I'll scroll back through. So starting point, we have our light pin. I went ahead and defined the two Boolean variables, PIR state, which is basically the light sensor and light value. And we have our constants for these frequencies. Then we have our speaker pin and our LED pin 1. Then we have our counter that we can use. So inside of void, we could use counter for this instead of X. I'm just going to leave it for now because it doesn't make a huge difference. It would make this smaller and more compact. So I guess if we did that, it would look like this, because we knew we were going to be doing a bunch of functions, and we say counter equals 0, counter less than loop time, counter increment. So that would be an example. Let me validate that that's actually what it is. Yes, correct. So we could use counter for make tone as a for instance. So we use make tone inside of beep. Beep had to get updated. Speaker is an awful lot quieter than it should be, and that's I don't remember if that's because we have to use a couple more of the speaker commands or what it is to actually set the output level, but it gives us a starting point. So a couple of you have figured out what it is. So we use make tone within beep. We commented out the other stuff. I also set it to digital write to the speaker pin low in order to turn it off in between, since I don't think no tone was working correctly. So then we increment the counter. Then we have first section. Then we have second section. We have delays. Our setup, I'm leaving the speaker pin as its default state instead of defining it to output, because I was trying to see if that would help me connect the external buzzer or not. And it seems like not, for whatever reason. Not real sure why it doesn't want to do that, but is what it is. I'm going to try one more small remedy as you guys are kind of cleaning some of this up. So LED pin serial begin. The loop starts with this light value. Then we have a serial print to check and make sure we know what exactly it's doing. And I'm going to do a quick wire strip to see if I can convince this guy to actually cooperate with the external buzzer. Is it really theoretically should? However, It may not cooperate with this at all. These can be a little bit on the tricky side to get to cooperate. So I was going to see if I could improve the connection. That's part of the reason why I don't like using the kind of cute, adorable little gator clip approach. But sometimes it has its place. So I'm going to connect up 1 to our analog 0. And 1 to our ground. See, I'll move this guy down so you can see the next part. So light value, digital write, that stuff is staying the same, looking for PIR state basically to reverse the status so that the trigger stays high. So it's a logic reversal that has to happen there. So let me see if I can get it to cooperate any differently. So okay. So I know we've got connection there. And let me see if we've got no, it just can't output. Nope. Just doesn't have. Yeah, doesn't have the juice to I would have to run an external resistor on those in order to get the output significantly higher. So things that make more sense in the context when you're working with an actual circuit. Why the I could probably help with running a pull up or pull down resistor command, but this at least gives you a starting point. Let me see if this part works correctly.
I have a quick question.
Yeah.
I was trying to type out that small function for make tone right there. And when I tried to verify it, it said it was not declared. I was wondering if I maybe missed something else that's not on screen.
So you basically what you're doing is you're declaring another class in this. So it has to have the void, it has to have the parentheses, it has to have the open close parentheses, and then it has to have the open and close curly braces. If it doesn't have those things, then the code itself can't recognize that it's supposed to be a function. That's one of the challenges that we're having. So I'm going to share this as an example. This is.
I found it. It was a letter misspell.
Okay. Yeah, that's the other thing that can happen is if you have make 10 or tani or something like that instead of make tone. It's all those little things that make all the difference. So what you'll end up with is in effect this, where you have our sensor acting as the light sensor here. And then this is just an example to manually trigger this. So same thing that the other sensor does. The signal pin is run into the same pin we ran a switch to. So headphone users have been warned. The folks that are asleep will be awake now. So that's what you're looking for as your end state. This is roughly the equivalent of what we're coding for on the board. We just happen to be using slightly different pin assignments because of the pin arrangement on the Circuit Playground Express. But it does actually play. I just don't remember offhand how to do better control of the actual volume because it requires an external resistor in order for it to work. So that way the effective current through that speaker would be higher. That's always one of the limiting factors. So that gives you a reference point for what it is that we're actually making happen. So the idea is you have multiple different functions that are each doing something. This one just happens to be one of them. There's some others that use some playground speaker commands, and that's one of the things that I was looking for to see if instead of this make tone, there are some ways to use some of the speaker commands. But let me see if there's another one. Let's see. Here we go. So there is in the library another one. Let me see if this one fixes our volume issue. So this is our make tone. I'm going to try for beep. I'm going to try this one. So I'm going to comment this one out. And I'm going to include the Circuit Playground command. So I'm going to go up and add the library. speaker tone, speaker pin, note, and duration, and see if that works better. But we have to include up here we're going to need basically the key spelling at a minimum is this one. So we need this one for sure. Because of the nature of the libraries that I've given you guys, I'm going to include both of these. So the Circuit Playground and the Circuit Playground underscore. That will allow us to access the Circuit Playground.playtone. And I forget if this actually works better for these, but they also they aren't designed to have the same volume range over everything, over all the frequencies. So I'm going to verify, make sure that this is still functioning. So even though I've left the make tone there, you can have a definition without doing other stuff. And look, when we included the Circuit Playground libraries, our volumes of data doubled because reasons. So we're going to upload it. And I have not been able to relocate the super duper secret cheat sheet for all of the commands that are off label, which is pretty crazy. Oh, that's terrible. Excellent. That's really bad. Ours worked so much better. Okay. So I mean, you can try and use that function. It'll chirp more or less. But that's about it. Okay. So that's genuinely terrible. That's really not a tone. That is disappointing. Okay. No, that's not what I was looking for. Let's see. Let's see. Okay, so that does not work well. Yeah. That's really what it comes down to is you have to hook it to an external speaker, and I just don't have a high enough quality gator clip to be able to connect to a larger speaker. That's disappointing. I don't have that kind of hardware lying around, even though this is effectively an electronics lab. So that's disappointing. All right.
Do you know why the Circuit Playground Express is like really having a hard time like making a loud sound?
I mean, I know part of the reason is these are in fairness, this is it's running off of a number of effectively milliamps from a board. It can accept anywhere from a 3 to a 6 volt battery, but it doesn't have a lot of current to play with. So it's never going to be super duper loud. Also, this speaker is physically like smaller than an average pinky nail. So the speaker itself is not very big. There's not a lot of air movement from that speaker. So it's sort of the polar opposite of the dudes with a Lincoln Town Car, where they've got a pair of like 15s in their trunk and literally nothing else in the trunk because that's all it can fit. It's the sort of polar opposite of that. So
I gotcha.
there's physically not a lot of power to work with. So that is terrible. I'm going to go back to make tone. I think you can use a pull-up resistor on, I want to say you can use a pull-up resistor on A0, but maybe not. Because there are a number of speaker types. And here's a simple demo of what I was actually doing. Again, to give you guys a somewhat of a frame of reference.
By the way, they have the same function as the pins that you'd see in a traditional microcontroller, with the little insect legs soldered to the playground clips to the tip of the audio jack on your speaker. This is the wiring diagram, and this is what setup looks like in real life. So you can see where I've clipped things on the board and on the audio jack on my speaker. Cool. Let's save and play. Much louder. You don't need the extra speaker, but it's nice to have for projects. These speakers are also nice because many of them have some sort of volume control. The basic wave play code that I showed you in the prior lesson doesn't allow for you to programmatically control volume. I will show you some more advanced programmatic volume control techniques in a future lesson, but until then, I hope this helped, Pythonistas. Keep following.
So there's a few different examples of what that looks like, but that's effectively what I was doing externally. The problem is the buzzer I have is configured for 12 volts, and so it just shows up as a load. The only thing that it was helping to do was act as a higher, basically a higher resistance that was enabling the speaker to function at a slightly greater volume, but only intermittently. So I would have to repeatedly make contact and disconnect it in order for it to actually do the thing that was needed. So it would artificially boost the current through the little tiny speaker by applying a dynamic increasing resistance on the external pins, because every time the board is sending a signal to the speaker, you're energizing that A0 and you're energizing the A0 and ground is what you're really connecting stuff to. So there's a couple pieces there that we need to understand a little bit better. But this at least gives you a reasonable starting point for what a project might look like if you were going to do something like this, where, hey, somebody flips the lights on and you make a change based on what that input looks like. Okay. So this is a reasonable point at which we can pause So any questions on this, or any questions on this idea of functions? Yes, it's trying so hard to make sound is accurate. It's really trying hard to make sound. It just does not have a lot of power to draw from. So, questions on this? I do know there's some messages and things. I'm trying to get a couple other classes all caught up so that we can make some headway, both in messages and the get the grading completely up to date. We are going to be doing another quiz coming up fairly soon. I'll have to look at what's going to be covered on that because I don't know yet. But it'll be similar format to the last one. So this is as reasonable a point as we're going to find to wrap up for today, because I know these are very hard, long sessions for you guys. We're going to get a little more into, now that we've kind of done functions, we're actually going to start putting functions into libraries as an example of how to do this so that we could use that make tone elsewhere, for instance, and see what you guys are doing. So if there's no other questions, then I will see you guys on Thursday.
Have a good day.
You guys too.